In this module, we will discuss the aircraft's fuel system. We will start with a system description. Controls and indicators will be covered next, followed by servicing and normal operations. The aircraft incorporates 3 tanks. The main tanks are located in the wings. The number 1 tank is in the left wing, while the number 2 tank is in the right wing. A third tank, called the center tank, is located in the fuselage in between the wing roots and extends out into the wings. Each main tank has a usable fuel capacity of 8,630 pounds. The center tank's usable fuel capacity is 28,803 pounds. Each tank is serviced by a pair of AC electric fuel pumps. All the fuel pumps are located in the center tank. Fuel is drawn from the wing tanks by manifolds connected directly to each wing tank pump. The wing tank pumps are labeled forward and aft. The center tank pumps are labeled left and right. Fuel is drawn directly from the center tank. The fuel pumps are cooled and lubricated by the fuel passing through the pump. The center tank pumps produce a higher pressure than the wing tank pumps. This ensures that the center tank fuel is used before the main tank fuel. As you can see on this diagram, one pump in each tank is powered by the opposite transfer bus. This arrangement ensures that at least one pump in each tank will remain powered in the event of a single generator. The number 1 engine is normally fed by the number 1 tank pumps and the left center tank pump. Engine number 2 is normally fed by the number 2 tank pumps and the right center tank pump. Fuel is supplied to a common manifold which is divided into the left and right side by a fuel crossfeed valve. Check valves prevent the backflow of fuel into a particular pump and the transfer of fuel between the tanks. A pressure sensor, located prior to each check valve, monitors the pressure output of each pump. Each wing tank incorporates an engine bypass valve that enables each engine to suction feed fuel in the event of a loss of the fuel pumps. The engines may flame out if they are suction feeding above 30,000 feet. These bypass valves are also used for defueling operations. Due to the lack of bypass valves in the center tank, the engines cannot suction feed fuel from the center tank. Therefore, if both center tank pumps fail, center tank fuel will become unusable. The left manifold is also connected to the APU fuel line through the APU fuel shutoff valve. A DC-powered APU fuel pump is located in the left wing tank. This pump supplies fuel to the APU fuel manifold and automatically operates when the APU fuel control unit senses low fuel pressure and shuts off when AC fuel pump pressure is restored. Fuel from each manifold flows through a spar fuel shutoff valve into its respective engine. The position of the spar valve is controlled by the respective start lever and fire handle. The spar valves are powered by the hot battery bus. Due to the location of the center tank pump intakes, a small amount of fuel remains trapped in the bottom of the center reservoir. This fuel is pumped into the number 1 tank through a center tank scavenge jet pump. The fuel scavenge shutoff valve opens when the number 1 main tank is about 1/2 full. Fuel pressure from the main tank number 1 forward pump operates the center tank scavenge jet pump through a Venturi effect. Therefore, the forward pump in the number 1 tank must be operating. Fuel is transferred at a rate of 177 pounds per hour. Once the transfer is started, it will continue for the remainder of the flight. 2 surge tanks prevent the excessive buildup of pressure within the tanks. These surge tanks are located outboard from each wing fuel tank and vent through a single opening under each wing tip. The fuel accumulates in the vent tank and returns to the tanks. Fueling and defueling is accomplished from the single-point refueling station located in the right wing leading edge. This panel is used to refuel, defuel, and perform tank-to-tank fuel transfers when the aircraft is on the ground. There is no capability to transfer fuel while the aircraft is in flight. Since the maximum takeoff weight is not much greater than the maximum landing weight, there is no provision for fuel dumping. Let's look at the controls and indicators associated with the fuel system. The controls and indications for the fuel system are located on the overhead panel, the upper display unit, and the right wing leading edge. Tank quantity is displayed on the upper display unit. The indicators display fuel quantity in pounds. The quantity indicators require standby AC power to operate. Fuel quantity is indicated for each tank with an accuracy of plus or minus 2.5%. Total fuel quantity can also be found on the Performance Initialization page on the CDU. The fuel quantity indicators provide alerts for low fuel quantity, improper fuel system configuration, and fuel imbalance. These alerts consist of a label in the affected tank quantity indicator immediately beneath the numerical indication of the fuel quantity. A low label indicates that the fuel quantity in the affected main tank is less than 2,000 pounds. When the label is displayed, the affected fuel quantity arc and digits are displayed in amber. The low fuel quantity indication is removed from view when the fuel quantity in the affected main tank increases above 2,500 pounds. There are no low fuel quantity warnings for the center tank. A configuration label is displayed immediately below the center tank quantity indicator when the center tank quantity is greater than 1,600 pounds, center tank output pressure is low or non-existent, and either engine is running. When the configuration label is displayed, the fuel quantity arc and digits on the center tank turn amber. The label is removed from view, and the quantity indications return to normal when the center tank quantity drops below 800 pounds, one center tank pump is supplying pressure, or both engines are shut down. An imbalance label is displayed when the main tank quantities differ by more than 1,000 pounds. The label is displayed under the numerical quantity indication for the low tank. In addition, the affected tank's fuel quantity arc and digits turn amber. The imbalance indications are removed when the fuel imbalance is reduced below 200 pounds. The imbalance warning is inhibited when the aircraft is on the ground or when a low fuel condition exists. The fuel temperature indicator, located on the fuel control panel, displays the temperature of the fuel in main tank number 1. The fuel panel incorporates a simplified system schematic. The location of the pump switches on the schematic indicates the approximate position of the associated pump within the fuel system. The lines depict the actual fuel feed from the pumps to the engines and the cross-feed manifold. Indicator lights provide a status of various components of the fuel system. We will now look at each of these components. The blue engine valve closed light indicates the position of the respective engine fuel valve. The engine fuel valve is powered by the battery bus and controlled by its respective start lever and engine fire switch. Since the start lever controls the engine valve closed light will illuminate brightly momentarily during an engine start and then extinguish. The engine valve closed light is extinguished when the fuel valve is open. The engine fuel valve is open when both the associated start lever is in idle and the associated fire handle is down. Fuel will flow into the engine in this configuration. The engine valve closed light is dimly lit when the associated engine valve is closed. The valve is closed when the associated start lever is in the cutoff position or the associated fire handle has been pulled. The engine valve closed light is brightly lit when the valve is in transit or the valve position disagrees with the commanded position. The spar valve closed light indicates the status of the spar valve. The spar valve is controlled by the associated start lever or the associated fire handle. The spar valve is powered by the hot battery bus. The spar valve closed light is extinguished when the associated spar valve is open. The spar valve closed light is illuminated bright when the associated spar valve is in transit or not in the commanded position. Since the start lever controls the spar valve closed light will illuminate brightly momentarily during an engine start and then extinguish. The spar valve closed light is illuminated dim when the associated spar valve is closed. The filter bypass light indicates that the fuel feed to the associated engine is about to bypass the fuel filter. This light will be discussed in the engine module. The position of the crossfeed valve is controlled by the fuel crossfeed selector. Rotating the selector 90 degrees opens the fuel crossfeed valve and connects engine 1 and engine 2 fuel manifolds. The crossfeed valve is powered by the battery bus. The position of the crossfeed valve is indicated by the blue valve open light. The valve open light is extinguished when the crossfeed valve is closed and the crossfeed selector is selected to the closed or vertical position. The valve open light is dimly lit when the crossfeed valve is open and the crossfeed selector is in the open or horizontal position. The valve open light is brightly lit when the valve is in transit or the valve position disagrees with the commanded position. In this example, the knob has been moved to close, but the valve has failed to move to the commanded position. Therefore, the valve open light is illuminated bright. The fuel pump switches control their respective pumps. Each main tank pump output pressure is monitored by a pressure sensor. When the pump output pressure decreases below 6 psi, the associated low pressure light will illuminate. For main tanks 1 and 2, the low pressure light is armed at all times, regardless of the pump switch position. The fuel annunciator light and master caution lights will illuminate if both main tank low pressure lights for a particular tank are illuminated. The fuel annunciator light and the master caution lights will illuminate on recall if only one low pressure light is illuminated. For the center tank pumps, each low pressure light is armed only when the respective center tank fuel pump switch is on. The light will illuminate in the event the associated center tank pump switch is selected on and the associated center tank pump pressure is low. The center tank low pressure light will extinguish when the associated pump switch is placed off or fuel pressure is within limits. The fuel annunciator light and master caution lights will illuminate if both center tank pump switches are on and both low pressure lights illuminate, or one center tank pump is selected on with the other one off and the operating center tank pump low pressure light is illuminated. The fuel annunciator light and master caution lights will illuminate on recall if one center tank low pressure light is illuminated. We will now cover the servicing of the fuel system. The fuel servicing panel is located on the forward part of the right wing, outboard of the engine. The refueling panel is powered when the access door is opened. The refueling panel can be powered by the APU, a ground power cart, or the aircraft battery. The battery switch must be on in order to refuel the aircraft using the battery only. The fueling station panel consists of controls and indicators used to fuel and defuel the plane and transfer fuel between tanks. A fueling manifold connects the single-point refueling station with fuel lines going into each of the 3 tanks. 3 valves, one for each tank, control how the fuel is distributed and the amount of fuel to be dispensed in each tank. The valves are controlled by 2 position toggle switches. When a fueling valve switch is selected to open, its respective light illuminates blue, provided that the associated tank is not full. The blue light only indicates that the solenoid is energized. It does not necessarily mean that the associated valve is open. If the tank is full, the associated fueling valve will not open, and the associated position light is extinguished. A fueling valve automatically closes when the associated tank is full. When a tank is filled to less than full, the refueler must terminate the fueling when the tank fuel quantity reaches the desired level. Fuel quantity indicators display the total amount of usable fuel in the respective tank. The fuel quantity indicators can be tested by placing the fuel door switch bypass switch to the test gauges position. The fuel door switch bypass position energizes the fueling system. If the fueling system fails to be energized when the access panel is opened, use this switch to power the system. Fuel can be transferred between tanks while the airplane is on the ground. Fuel from a wing tank or center tank can be transferred by opening the crossfeed valve and turning on the fuel pumps in the tank with the excess fuel. Opening the manual defueling valve supplies the fuel to the fueling panel area, and this fuel is then redirected into the receiving tank by opening the associated fueling valve. To terminate the transfer, close the tank valve switch and the manual defueling valve. Also, turn off the boost pumps and close the crossfeed valve. In this example, fuel is being transferred from tanks 1 and 2 to the center tank. Note that the crossfeed valve is open to prevent fuel imbalance. The manual defueling valve and the center tank fueling valve are opened. The fuel from the crossfeed manifold is directed to the center tank. The quantity of fuel in each main tank can be measured using float sticks. 6 sticks can be accessed from the bottom of each wing. The center tank has 4 sticks. The float sticks are gently pulled down. When the stick hangs up, read the graduations on each float stick. The stick reading and aircraft attitude provide the required references to obtain fuel quantity readings from data tables. Let's now look at the normal fuel system operation. During the pre-start check, check that all filter bypass lights are extinguished. Also, make sure that the engine valve closed and spar valve closed lights are illuminated dim. Next, check that the crossfeed selector is closed and that the valve open light is extinguished. Open and close the crossfeed valve to verify proper operation. Finally, place all fuel pump switches on and verify that the associated low pressure lights extinguish. This indicates that the pumps are operating normally. During all phases of flight, care must be taken to ensure that a fuel imbalance does not develop. A fuel imbalance occurs when there is a difference between the fuel quantity in each main tank. The maximum allowable fuel imbalance is 1,000 pounds. We will now go over the procedure to correct a fuel imbalance. An imbalance condition can be corrected by opening the crossfeed valve. The valve open light will illuminate brightly and then will immediately dim, indicating that the crossfeed valve is open. Next, the pumps in the tank with the lowest quantity are turned off. The low pressure lights will illuminate. The fuel pumps in the tank with the highest quantity are now supplying both engines. After the tank quantities are even, the fuel system is returned to normal by first turning on the pumps that were shut down earlier. Next, the crossfeed valve is closed, causing the crossfeed valve open light to first illuminate bright blue and then extinguish. The engines are now being supplied separately from one another, and both main tanks are being utilized. This concludes the presentation on the fuel system.